to Introductory Algebra. Let's get started with section 1.1, notation and symbols. So this section is going to have just kind of a wide variety of things that we're going to see. I'm really hoping that a lot of it is kind of a review. So if it is, just kind of speed through this video and then go do the homework. But if it's not, if you see something that it doesn't look terribly familiar, stop and really pay attention to it. All right, so variables. A variable is a letter that is allowed to vary in value. So the letter A, the variable A, could be 6, it could be -3, 5, a third. It could be a whole lot of different things. And that's really what it means to be a variable. Variables can change their value. Okay? They're not stuck like a regular number, right? 3 is 3. X, who knows? Some symbols. A is equal to B. That means A and B are actually the same thing. That's probably the symbol we're most familiar with. A is not equal to B. It means that A and B are not the same thing. They just aren't. A is greater than B means A is the bigger, not the bigger side. A is less than B means A is the smaller side. Now these last two are greater than or equal to and less than or equal to. And they're a little bit trickier because, for instance, with A is greater than or equal to B, we could say 3 is certainly bigger than 2, but why would you use greater than or equal to instead of just greater than? Well, what happens is eventually we start doing this with letters, and we might say something like X is greater than or equal to 2. And so we use it with letters because then X could be 2, and it would make a true statement. But it could also be 3 or 9 or 500, and it would still make a true statement. And you're saying, okay, but why do we need that? Well, if you run a business, you need to turn a profit. Okay, and maybe your business needs to make at least $10,000 worth of profit in a month to stay afloat. So you could set up an inequality that says, something like profit is greater than or equal to $10,000. And what that means is if you hit 10,000, you're okay, but you're certainly not going to be unhappy if you get past 10,000. And so we can use that symbol too. All right, so we've got a lot more stuff in this section, and I have to change my board. All right, continuing on through some notation and symbols. We have 4 basic math operations: add, subtract, multiply, and divide. And you'll notice that I have included the keywords that we sometimes use for these kinds of problems. So for addition, the keyword is sum. And of course, we hopefully all know how to write an addition problem, right? We use a plus sign. Subtract would be a difference, 2 minus 3. Multiply is what we call a product. And there are a lot of different ways to write multiplication. We can do it with a little x in between, but here's the thing, we're not going to do that very much in this course because we're going to start doing algebra, which means x is going to be the variable we use the most often. So you won't see very many cases where you have x as a multiplication sign. We can have 2 and then parentheses 3, or both of them in parentheses. And then we could have, in this case, 2 times x or x times y. Basically, in math, if you take a number and a letter and smush them together, it's always multiplication. Or if you have 2 numbers and they're smushed together like the 2 and the 3 here, it's always multiplication. Okay, so that's important to know. And then finally, we have division, which is a quotient. 2 divided by 3 is the same as the fraction, 2 over 3. Okay, so a fraction is a division problem. We'll talk more about that when we get to fractions. And the same problem here would have 2 on the inside of the box if you were to set this up as a long division problem. We have some grouping symbols that we need to look at. We have parentheses, brackets, braces. You really hope you don't have to draw those too often. They're a bit of a mess. And actually a fraction bar acts as a grouping symbol. And so we're going to get to the order of operations here in a few minutes. But so hopefully you remember with that order of operations that you do what's on the inside first, and so that's what grouping symbols are really for. So with a fraction, the top part of the fraction counts as one group, and the bottom counts as the second group. So you'll have to deal with that. All right, let's keep going. All right, so we're back. Exponents. So an exponent is a little tiny number put kind of up on the upper right-hand side of another number. The number at the bottom is called the base. In this case, that's a 5. The exponent here is a 3. You may or may not be able to read that through my camera. I hope you can. But 5 to the 3rd power means that we are going to multiply 3 5s together. So the exponent tells us how many of the base to multiply together. And so in this case, 5 to the third power ends up equaling 125. So basically, it's shorthand for repeated multiplication. All right, the order of operations. Please excuse my dear Aunt Sally, or PEMDAS. People usually learn this one of those two ways. So please excuse my dear Aunt Sally, or PEMDAS. I have problems with both of them, and we'll talk about that here in a second. So the order of operations is this: parentheses, exponents, multiply and divide from left to right, and then add and subtract from left to right. So PEMDAS, or please excuse my dear Aunt Sally, comes out of the first letter of all of these. Please excuse my dear Aunt Sally, or PEMDAS, P-E-M-D-A-S. Now, the reason I don't like it is because people frequently get mixed up here with multiplying and dividing and with adding and subtracting. Multiplication and division are one step. They always go from left to right. Okay, so even though multiplication comes first when we say please excuse my dear Aunt Sally, if the division comes first going from left to right, we're going to do that first. They are the same step and they always go from left to right. Same thing with addition and subtraction. All right, so now I'm going to clear off this board. I'm going to put some helpful suggestions up for the order of operations, and we'll do some examples. Great, here we go. All right, so here I have my helpful hints, and then also I have the first two examples. We'll probably do one more. So I put PEMDAS back up here just as a refresher for us, but you can certainly go back and see the full list of the order of operations. So here are my hints. Do one thing at a time. Okay, some of you are going to be really good at this, and you can kind of combine steps. But if you're not confident with this, if you find that you're not getting right answers very well, try to do just one thing at a time. Okay, do one thing, rewrite the problem, and then start again. Okay, it's just easier to really focus on one thing. 2, if you have scratch work, take it off to the side of the problem. Okay, some people even like to split their paper in half and have the problem on one side and the scratch work on the other. And that's a wonderful idea, because when the scratch work kind of gets mixed into the problem, it tends to make things messy and it's harder to get right answers, which actually brings me to my third point. Be neat. So some of you have amazing handwriting that I will look at and be like, whoa, that is awesome. And some of you look like a bomb went off on your paper and you've got stuff everywhere and it's really hard to read. I'll do my best, but here's the thing. You have to be able to sort through what you're doing. And if you're neat, it's much easier to do that. So if you find that you are a bit of a messy writer, a messy organizer of your paper, really focus in on that. It's a good skill to learn. All right, so I have my first two examples up here. First one is 7 plus 8 times 6. Well, according to PEMDAS, multiplication beats addition. So we do the 8 times 6 first, which gives us 48. Then we add and get 55. Not too bad. Second one, this one's a tricky one. A lot of people miss this problem. So here's what we have. 100 divided by 10 times 5. This is where please excuse my dear Aunt Sally and PEMDAS can get in your way. Because if you look at PEMDAS, what comes first? Multiplying and then dividing. But remember, we said on the last board that multiplication and division are one step, and they always go from left to right, which means that the 100 divided by 10 has to go first. Okay, even though, but you're like, oh, the M is first. I know, but they're really together. So try and remember that. We do divide, we get 10. 10 times 5 is 50. All right, let's get some more examples. All right, so here you'll notice I have one very large example, including an arrow that takes us up to continue the problem up on the other side of the board. All right, here's what we have. 3 squared plus 5 times brackets, parentheses, 9 times 2 plus 1, minus 4, end of brackets. It's a big mess. So where do we start? PEMDAS says parentheses first. So you go, okay, I'll do the parentheses. Inside the parentheses, we have multiplication and addition. Multiplication wins, so we get 18. I'm going to keep doing my parentheses. 18 and 1 makes 19. Now I have to finish those brackets. We started on the inside with those parentheses on the inside. Now we're to the brackets. 19 minus 4 is 15. Great. We finished everything on the inside, so now we move on to exponents. 3 squared, 3 times 3 is 9. Okay, here's a really important step. Next is 5 times 15, which you can see over there gives me 75. It's really common, and it's unfortunately very wrong, to do 9 plus 5 first. Okay, I get it, it's staring you in the face. It's like, hey, add these two numbers. But you can't. Remember, multiplication wins, and this is multiplication, so it has to come next. That gives us the 75. We add, and we get 84. So that's really, this one right there, that's really something big to watch out for. A lot of people get tripped up by that. Almost done. All right, so the last thing we're going to look at in this section are a couple of kinds of sequences. All a sequence is it's a list of numbers that proceeds according to some sort of rule. Okay, whatever that rule might be, that's how you find the next number in the sequence. So we're going to look at two kinds of sequences, or arithmetic sequences and geometric sequences. An arithmetic sequence is addition. You're going to add the same number every time. By the way, it also works with subtraction, so you can watch out for that later when we get into negative numbers. So for instance, I have 7, 12, 17, 22. That's the start of my sequence. The sequence is going to go on forever. The rule is we're adding 5, right? 7 and 5 is 12. 12 and 5 is... So if we wanted the next three numbers, we could just keep adding 5. And that's an arithmetic sequence. A geometric sequence is going to use multiplication. Okay, or again, it could use division. So we're going to multiply by the same number each time. In this case, I have 2, 6, 18, 54, 162. Turns out the rule is that we're multiplying by 3. 2 times 3 is 6 times 3. It works. So here's the thing. If you know you have an arithmetic sequence, you can always subtract any two numbers to find out what you're adding. 12 minus 7 is 5. If you know you have a geometric sequence, you can divide those two numbers. Make sure you do the second one first. 6 divided by 2 would give you the 3. And that way, you can know how to proceed with your sequences. So there you go.